Okay, so I'm going to do a video to help you with reciprocal graphs 1 and 2, and specifically what to do with the horizontal and vertical asymptotes. So I'm going to start by showing you a sketch of y equals 1 over x. Okay, make sure I'm in shot. So the graph of y equals 1 over x looks like this. As x gets really, really big, y gets really, really small. When x is really, really small, like 1 over 1,000, a thousandth, then 1 over it becomes 1,000, so it becomes really, really big. Same happens, but with the negative in the negative quadrant. So we've got two, what we call asymptotes. An asymptote is a line that the graph is desperately trying to reach, but will never ever manage it. So here, the graph is trying to reach y is equal to 0. So the x-axis has an equation y equals 0, and the y-axis has the equation x is equal to 0. And these are both asymptotes. The graph is trying to reach the y-axis and never will. The graph is trying to reach the x-axis and never will. So they're called asymptotes. This is a vertical asymptote. This is a horizontal asymptote. Now, to understand the questions on Hegarty Maths, you need to understand graph transformations, which we've done. Hopefully you've done those videos beforehand. If not, that's why you're struggling. So let's have a look at some graph transformations. So let's have a look at what happens if we do something inside the bracket. So if we make f of x equal to 1 over x, then f of x plus 3 will be inside the function, and the function is to do the reciprocal, flip it over. So this will be 1 over x plus 3. So the ones that are all inside the fraction are happening inside the brackets. They're affecting the inputs. Now we know that when we affect the inputs, we do the opposite of what's in the bracket because it becomes like solving an equation. So this means that all of the x units have moved 3 to the left. It's plus 3 does the opposite and moves 3 left. So if all of the x units have moved 3 left, how does that affect our graph? Well, if we go back and look at our graph, if everything here has moved 3 units left, then all that's happened is this asymptote will also have moved 3 units left, and your asymptote, instead of being x is equal to 0, will in fact be x is equal to minus 3. Your graph will move 3 left and it will actually look like something like that. Okay, so if we go back to our function, so when they're inside the function, so if I had f of x minus 5, that would move 5 to the right. So that means that the asymptote would move 5 to the right. So instead of being x equals 0, after the transformation, it would become x equals, go 5 to the right, 5. Okay, so your vertical asymptotes will change if your transformation is inside the brackets, affecting the x values. Right, so what about the other type then? How do we affect the horizontal ones? Well, if we've got f of x plus 3, we know that that's going to move the graph 3 units up. What does that look like as an equation? We take our f of x, 1 over x, and then we add 3. So the graph of 1 over x plus 3 is a function plus 3. It's happening outside of the function. It's affecting the y values. It moves the graph 3 up. When it's outside the function, it does what it says on the tin. So what does that mean? Well, if these were my original asymptotes, if my whole graph is moving 3 up, then my asymptote is also going to move 3 up, and that will be y equals 3. And then I can draw in my graph. This graph won't change. The asymptote won't change. The asymptote will still be the y-axis. but the horizontal asymptote will change because it will move up. So if you've got 1 over x plus 3, your asymptote is going to move 3 up. If you've got, let's find a little bit more space. If you've got 1 over x take 1, then that's affecting the inputs, it's affecting the brackets. That's f of x minus 1. That moves the function 1 to the right. So if we're moving 1 to the right, the vertical asymptote's going to move 1 to the right, and you'll get x is equal to 1 would be your asymptote. I hope that helps. If it doesn't, email me back.